In this section, we're going to look at question 10 from the January 2021 CSEC Mathematics past paper. So here you have the matrix W as 3, 6, minus 2, 5, and you're asked to determine the 2 by 2 matrix L such that W plus L equals to 0, 0, 0, 0. So we have the matrix W as 3, 6, minus 2, 5. And when we add it to a matrix L, we get 0, 0, 0, 0. So the matrix W plus L, which we don't know, but it's very straightforward. So when you add the corresponding elements in the matrix, you should get 0, 0, 0, 0. So this one is very straightforward. So what element must be added to positive 3 to give you 0? And that's going to be minus 3. And also the element that to be added to 6, there should be minus 6. And that should be positive 2. And that should be minus 5. So the matrix L is minus 3, minus 6, 2, and minus 5. Let's go on to part 2. So it says determine the 2 by 2 matrix P such that W times P gives the matrix 1, 0, 0, 1. This matrix here, at this level, if you're studying, you should know that it's the identity matrix. And a matrix times its inverse gives the identity matrix. So all we need to do is to find the matrix, find the inverse of the matrix W. So we have the matrix W as 3, 6, minus 2, 5. So the matrix P should be the inverse of W. So P, let's write that down. P equals to the inverse of W. P equals to W inverse. And how do we find the inverse of a matrix? Well, it's we're going to have to find the determinant of W, and then we're going to do some more things. So first thing is to find the determinant of W. So determinant W would equal to, we multiply the elements in the leading diagonal, so that would be 15. 3 times 5, that's 15, minus we multiply the elements in the non-leading diagonal here, so you're going to minus the elements in the product of the elements in the non-leading diagonal. So that's minus 2 times 6, that's minus 12. Okay, so the determinant there is 27. Now the inverse is going to be 1 over the determinant. So W inverse is 1 over the determinant, which is 1 over 27 there, times, we're going to do a few things here. First, we interchange the elements in the leading diagonal. So here we're going to have 5 and then 3. And then the elements in the non-leading diagonal, we multiply them by minus 1. So minus 1 times 2 there is going to give us positive 2. And minus 1 times 6 there gives us minus 6. So the matrix P is going to be this matrix here. So we can write 5 over 27 as the first element. So the matrix P there, there should be, let's just write it out. So the matrix P is going to be, that's going to be 5 over 27. And the element there is going to be minus 6 over 27. And that's going to be 2 over 27. And that one is 3 over 27. And when you multiply these two here, you should get the identity matrix, which is 1, 0, 0, 1. Now, there's another way how you could do this. You could put letters, say for example A, B, C, D, and then you multiply this matrix with the matrix A, B, C, D, and equate them to get, and then you can solve the simultaneous equations to get the values here which we have. But at this level you have seen that this is the identity matrix, and the matrix times its inverse gives the identity matrix. So just find the inverse of the matrix, and then that is it. So the matrix P, let's just write that out. The matrix P, so the matrix P there equals to, so the matrix P equals to 5/27 minus 6/27 and 2/27 and then 3/27. So that's the matrix P. Let's move to the next part of the question. Okay, so part B, we have a right angle triangle M, and we have the vertices X, which is 1, 1, Y, 3, 1, and Z, 3, 4. And it says M is transformed by the matrix N, which is 0, 1, 1, 0, and you're required to write the image of M. So we have a right angle triangle matrix M, which is X, Y, Z. So we have N. So we have the N as 0, 0, 1, 1, 0, and we transform the matrix M as X there is 1, 1, Y is 3, 1. We have Y as 3, 1, and then Z as 3, 4. So to get the image of M, which is a triangle, so we have a triangle, a right angle triangle as X, Y, Z, and we transform it with this matrix N to get that. So let's now work this out. So we're going to have row times column. So 0 times 1 is going to give us 0, plus 1 times 1 is just 1. So that coordinate, that element there is just 1. And then we have 1 times 1 is 1, plus 0 times 1 is just 1. So we get the first coordinate there, and then then 0 times 3 is 0, and then 1 times 1 is just 1. And then we have 1 times 3, that's 3, plus 0 times 1, that's 0. So what we have there is 3. 0 times 3, that's 0, plus 1 times 4, that's 4. And then 1 times 3, that's 3. And then 0 times 4, that's 4. So what we have there is just 3. Okay, so the vertices of the matrix M prime there is given as 1, 1, 1, 3, 4, 3. Let's have a look and see if we have any more questions at the bottom there. That's the end of that. So now we go to part C. So here we have a diagram which shows a triangle OPQ, and it says that OP is 3U, OP is 3U, yep, and then OQ is V. Q is the midpoint of OR, so OR is this length here, and Q is the midpoint, and then and then M is the midpoint of PQ. So we have PQ and M is the midpoint of that, and it says L is a point on OP such that OL is 2/3 of OP, so that's right. So you are asked to write in terms of U and V an expression for LM. So LM there is going to be, let's just move that out of the way, LM is this part there. Okay, so we just need to make this a little bit smaller. Okay, so LM is that. So we want the resultant LM there. So to get LM, to get LM, we're going to have to travel along this route here, LP and then PM. So LM is equal to LP plus PM. Okay, so how can we get PM? Well, we're going to have to find PQ because it says that PM is half the length of, is the midpoint of PQ. So if we find PQ, we would get PM as half the length of PQ. So let's find PQ first. PQ. So from this, PQ would be PO plus OQ. So PQ, it would be PO plus OQ. PO, all of this length here would be 3U. Okay? So OP is 3U. So PO would be minus 3U. So we would have minus 3U plus OQ as V. Okay? So if we have PQ, then PM is half the length of PQ. So what we're going to have there is LP as U. So we have U plus a half. Since PM is half PQ, so it's going to be half of V minus 3U. Half V minus 3U. Okay? And upon simplifying that, what we get there is a half into V minus U. So you can simplify that to see that it's a half into V minus U. Okay. Now, we want to go to the next part of the question. Okay, so, right, let's see what we have there. So we have that. So we want to find now PR. So let's find PR. That's the next part of the question. Let's go back and have a look and see what we have there. PR. We want to find PR. PR, yep. We want to find PR there. So PR. So to find PR, we draw this line here, PR. Okay? And what we want to do, we want to find the resultant PR on the diagram. So this is going to be our resultant then for PR. So PR would be PO plus OR. So PR equals to PO, let's just go back there, PO plus OR. So PR there would be PO, so that would be minus 3U plus OR there would be 2V, because if OQ is the midpoint of OR, it means that QR would be V as well. So it means that the full length of the line here, OR, is 2V. 2V. Okay? So PR is minus 3U plus 2V. Okay, so let's go to the next part of the question. It says that you need to prove that L, M, and R are collinear. So let's extend this line here, L, M, and R. So we have L, M, R. We need to prove that they are collinear, which means that they lie on the same line. Okay? I think okay, so to prove that they are collinear, it means that we need to prove that L, M, and R they lie on the same line. But this is not to scale. So it means that if they are collinear, it means that L, M, and R should lie on the straight line. And we can prove that by finding L, R, and then compare it with LM. We have found LM previously. So LM, we had found that as, let's go back to question. So LM was a half. Let's see if that's, we can make this bigger. LM was a half V minus U. So we have found LM as half V minus U. So let's go back to this. So to prove that they are collinear, we need to find LR and prove that LM and LR have the same ratio. We know that LM was a half V minus U. So let's find LR. The resultant LR there is going to be LO plus OR, and this is V. That's V. So the full length there is going to be 2V. Okay? So LR, let's go there. LR is going to equal to LO plus OR. LO is going to be minus 2U plus 2V. And we can express that as 2 into V minus U. So you can see that they have the same ratio. So you can just say L, M, and LR have the same ratio. Therefore, they are collinear. Therefore, they lie on the same line. So you can write L, M, and LR have the same ratio. Hence, they are collinear. They are collinear. Okay? Let's just write that properly. My pen is giving some issue here. They are collinear. You could also go on to express the ratio of Lm to Lr. So the ratio Lm to Lr, Lm is a half V minus U, and Lr is 2 V minus U. So you can write the ratio as a whole, so that would be 1 to 4. The ratio there would be 1 to 4. So you can write V minus U, and that would be, in the ratio there would be V minus U. Okay, so it's 1 to 4. So it means that the ratio of Lm to Lr would be 1 to 4, but also you can see that they have the same ratio, so they lie on the same line. So here ends question 10.